say, yeah, are you willing to be recorded? And the answer is, well, I'm only going to be displaying the stuff that's relevant. So probably you're fine. Um, so maybe what we could do is start with me reminding you of a couple things administratively, and then take some administrative questions, then tackle any subject matter questions you might have from recent material, and then go into the topic of the day today. Okay, so administratively, one thing I wanted to mention is there's this final coming up. It's just something we should do. I hate finals. Actually, they're sort of cool in some ways, but um, you know why they're cool? It's when people actually study for exams that they sort of get a better understanding of the material often. At least sometimes you get a better understanding of what you know and you don't know, and then like that causes panic. But at least you know better what you do and do not at the current moment understand. So that's always a good thing. The knowledge that you gain from that last push towards the finish line. So there's this final coming up. It's officially due Tuesday of finals week because this is one of those timed classes where in a window it's not asynchronous. And because it's synchronous, our final exam time block is Tuesday, 1 to 4 p.m. So I tried to suggest earlier, hey, you want to take the test with me there? And if you do, you could sign up for one of three times. I sent that around earlier. Sign up for one of those times if you want to be there. Or you can always check that box that says, I'm just going to take it when I feel like, but as long as you're done in time, we're all good. The reason is I've got this other class and they're going to be finishing probably later than you guys will because their due date is Thursday, 4 p.m. And so if I can start grading your tests earlier, that makes me a happier person than having to do a whole, 50 or 60 hours worth of work over the weekend. I really don't love that. But, we get what we get. And so Tuesday at 4, think that. Sign up for the Monday 1 to 4, the Tuesday 10 to 1, the Tuesday 1 to 4 time slot if you'd like to be in a Zoom room by yourself where essentially, a breakout room. And if you have a question, just flag me with the little fun blue hand and I'll pop my way over into your breakout room. And I'm happy to chat with you a little bit about the exam while you're taking it. You could ask me to rephrase a question, and I'm happy to do it. You could ask me, I don't understand this. Would you tell me? And I'll just say, no, I'm not going to tell you how to do a problem. But sometimes the rephrase itself really can be helpful. So I would recommend that if you are free during finals week, sign up for a time slot the Monday or one of the two Tuesday time periods when you could sort of be there in a breakout room. I think that's a good plan. There is a limit of 50 students per breakout room within a Zoom session, or 50 breakout rooms, I should say. So that's going to put a limit of 50 students at a time. But just let me know which of those times works. Um, Also, during finals week, office hours, I'm going to have some, and I'm leaning towards, but I have not committed to Monday, 10:30 till 12:30. 10:30 a.m. to 12:30 p.m. is about the best time window I can think of uh, before all three exams. Uh, Probably Tuesday morning would work out wonderfully, but I would have perhaps a limited amount of time between the end of my doctor's appointment Tuesday and the beginning of the final exam. So if possible, I will have an additional time slot for office hours, but that's going to be sort of close to last minute. Like I might let you know at 9 a.m. on Tuesday, hey, I'm free for an hour. If you have a question, pop on over. Okay, that would be via email that I'd let you know that. Also, just for your information, later that week, Wednesday, Thursday, and Friday, I will be in day-long meetings, three of them back to back, three full day meetings in Long Beach, which is hilarious because I'm not going to leave my kitchen for 3 days, but the meeting nominally is in Long Beach at the chancellor's office. So I can do email during that time period, but I probably won't be able to do a lot of interacting other than electronically via email or something like that. So that's my first set of announcement sort of things. Second thing is I emailed you all that Excel file where you could just pop your scores in there. Last I looked at the homework, not so many of the homeworks have been graded. Let's just say not many. And so you might want to just plug in a fairly sizable percent, like a 90% or so for your homework score, because I'm going to look through the homeworks and just give you credit for did you do it or not, unless the grader tells me, oh, no, I'll do it. But certainly the first initial homeworks, I would ask her to grade the later ones. But the first initial homeworks, if she hasn't gotten to it, I'm just going to give you credit for having done it or not. The answer's already there. You have the opportunity to look through your work, but I don't want to dump on you guys the burden of grading each other's homeworks. I'm thinking about that for future terms, ask students to grade each other's homeworks. Do y'all like that when that happens in your classes? Yu Chen says, F no. Okay, got it. Fair enough. But if I make the homework solutions available, at least there's that. Okay. And so you could key off of that. And the sample exam, I have not put the sample final exam online yet. I'm going to be doing that later today. And excuse me. Oh, I'm sure that sounded gross. But I'm going to do that later today. And after I do that, just look it over. And I would probably start with one, can I answer this question easily? Check or put an X. And if you can't easily answer the question, you know where to go. And then you say, okay, now that I've got all those check marks just out of the way mentally, where you just jotted down, oh yeah, this is ANOVA post hoc. Okay. Then you should spend a little bit of time thinking about what do I already know about these sample exam questions that I wasn't so sure about, and try to identify approximately what are the topics that would help you get to an answer. And then once you've done that, then maybe a little bit more study. So the goal really is on the sample exam to differentiate between, yeah, I already know it, and I'm sure I don't know it. And those middling ones, then put more time and care into classifying them as, yeah, I think I got it, or yeah, I'm pretty sure I don't. And then ask questions on Thursday about the questions, the problems that you're not sure about. That's really the goal of Thursday, is to spend the whole time talking about things that you want to talk about to help you get ready for the final exam. So that's, I think, the sum of all my administrative things. A couple students I have talked to about that sample, not the sample exam, but that Excel spreadsheet of, what grade would I get, et cetera, said that they thought it worked out pretty cleanly. But if you want to talk about that, we can, or anything else administratively. Any questions? Now is a great time.
So I
Yeah,
noticed.
go ahead. Go ahead, Daniel.
Oh, okay. I noticed that the weights that were used for determining the would-be grade are a little different. Like, for example, the weight for the labs are actually a little bit lower, and the weights for the exams are or the exams we already took are also a little lower than what was said on the syllabus.
I
So
think that was because the grade so far, I did the sum of what I knew times the appropriate percentages, if you will, and then divided through by 1 minus the percent that would be attached to the final. So that's a way of saying, if I were to keep the same grading scale, sort of like midterms are equal to each other, and midterms are worth, 1.5 times what a homework is worth, that sort of thing. if I were to keep that proportionality constant or set of proportionality constants, and then determine the final grade today, what would that be? Without the final exam. And so then we could plug in that final exam to see how that would impact things. So I think I did that correctly, but I will double check, Daniel. So thanks for mentioning that. Does that answer your question?
Yes.
Okay, and I think Maggie, you had a question too.
Yeah, after we decide which test we want to take, will it just be a link on Canvas to choose either one?
When I do release the exam, and I think I'm going to put it out there probably Saturday afternoon is about my target, once I get it finished, written, Saturday afternoon, there will be 2 links. One of them will be part E for everyone. Everyone has to take that. Yay, everyone takes it. And then part C, the comprehensive edition. Each of those 2 parts are, just think an hour and a half. They're each about as long as an exam that we've had so far. So if you're doing the math, probably it would be approximately 50% more time per question for the exam E for everyone. So just take that one first. If you're comfortable taking that one first, that's going to be the one that emphasizes just the most recent material. And then you'll see how you feel about that. And if you feel crappy about that test, or if you've already determined you want to take the comprehensive edition, give yourself a few minutes break at least, and then take that comprehensive edition, another hour and a half test. Again, the same number of questions as an exam that we've had so far, but that chunk of material will be evenly spread across the before the first midterm, between the 2 midterms, and since that second exam content. So think equal distribution on that comprehensive edition, equal distribution of points across the whole of the term. So does that answer the question, Maggie?
Yeah.
Okay. Anyone else want to follow up on Maggie's question? Because I think there's a couple natural follow-ups that are often asked.
Yeah, I just had I guess it's kind of similar. It's just general time frame. I think you might have said it, but I missed it. Was if we're gonna do the midterm in the final not in a Zoom room, when is the latest that we can do it?
Get it done by 4 o'clock on Tuesday.
4 o'clock on Tuesday?
Yeah.
Perfect. Awesome. Thank you.
Oh, yeah. And so about that, there's always someone who will have, computer problems or an accident or, a medical need. I had to drive my parent to the hospital, et cetera. Those stuff happens, and if it does, let me know and we can make adjustments at this end. But unless I have worked out something with you, make sure that you start in time to be finished with all the exams you want to be turning in by Tuesday at 4 p.m. So for the typical student, the latest you should start would be, if you want to do the comprehensive exam, probably about 1 o'clock, which gives you 2-3 hours to do the 2 hour-and-a-half exams back to back. If you like break, start a little bit earlier. If you're only going to do one of them, start at least an hour and a half before 4 o'clock. I would probably even start 2 or 2.5 hours before 4 o'clock because, stuff will sometimes happen technology wise. It's a drag to be, working inside Canvas if Canvas goes down and then takes 2 hours to come back up. Starting earlier has some benefits. So I think that gets to your issue, and I think we're in good shape there. Yeah, any follow-up questions on should I take the test? Yes. Okay. So,
Question, Ryan.
oh, sure, yeah.
Hi, I was able to make it today instead of asynchronous.
Woohoo.
So for the homework grading, though you said that you might have her grade just the later ones, or
Yes.
okay,
If she does reappear in my life
okay. If
via email, then I'll say, could you grade the last assignment?
okay,
And then the
if that-
one,
I'm
yeah,
sorry. I was
I'd
just
be the last two would be the ones I'd ask her to focus on.
okay, cool. Yeah. So is she gonna, are you gonna kind of advise her maybe to go, like, is she gonna be grading maybe a little easier than normal since we haven't had a chance to like see how the grading happens throughout the whole?
I don't even know what easier than normal for her would mean, so I can't comment on that, but I have told, when we did talk initially, I said, for homework for 513, the typical score, the average score would be like 85% of the points. And so that's sort of what I would hope that would happen. So if I do touch base with her, that's what I'll be reminding her of. And if that's not the case, when she sort of grades the first few questions, then presumably you could give full credit for the others, for completion, and that would raise things.
Thanks, just wanted to ask.
No, it's a good question. Okay, so quick summary of all of that is number one, probably if you did well on the first two exams, clocking at say 85% or higher, you'll probably want to take the Part E for everyone only, the non-comprehensive exam. If you were below about 85%, you might not be so sure. If you're below about 75% on average, you'll probably want to aim towards the comprehensive edition as well. When you look at the numbers, they are in your favor if you were to take the comprehensive exam, but you've done poorly because of time limitations. More time per question means it's easier to raise your grade if you do the comprehensive thing. So that's a good thing. Number two, be in the room if you want me to rephrase problems. That's never a problem for me. But if you don't feel you need that, that's okay too. Okay, any subject matter questions related to something we've done recently in the content? Model selection, perhaps.
I had a question about the last lab that we just turned in.
Yep.
I think I was a little confused in there about whether or not we should be like looking at adjusted or sequential sum of squares to determine some of those answers.
In most cases, adjusted sums of squares is the best approach to use because
Okay.
it tackles the question, if everything else in the model is already there, is this new term helping me?
Got it.
Every so often, a tightly worded question would require a sequential sums of squares analysis. If you want to control for some of the other x's, but not all of them, is the classic situation.
Yeah, there was just a question about whether there were any interactions, significant interactions, and first, when looking at the sequential sum of squares, it was significant, but not with adjusted.
So that would suggest, and I'm glad you brought that up, that would suggest if you're controlling for all of the other x's in the model, the interaction was not helping us.
Yeah.
But if you only control for some of the other x's, the interaction would help. Yeah.
Cool. Thank you.
Okay. Someone else. Okay, so what I want to do is to start in on this concept of logistic regression, and all of the individuals who replied saying, oh, logistic regression or random effects models, all the people I talked to said, yeah, logistic is what they'd prefer. So let me first off maybe introduce the topic of logistic regression in the context of an example. And it's an example that y'all remember from fourth grade. In fourth grade, okay, I shouldn't say all of you, but when you were in the California history class, which in California tends to be taught in the public schools at fourth grade, you learned about a variety of things like missions, and you did a little gold mine and all that sort of good stuff. But you all remember the sugar cubes and the missions out of a sugar cubes class? I thought that was the best, except for I kept eating the sugar cubes. And then once you start to glue them together, yeah, it's not as tasty because the glue, not as tasty. Okay. So one of the things you maybe did learn about was the Oregon Trail of people getting into California, or maybe they took a different route to get to California. The Oregon Trail was not the only route. One of the routes was much more direct from St. Louis straight across the Rockies, across the Wasatch Mountains in Utah, and then eventually the desert in Nevada, and you cruise up through Reno, across the pass, which is right now near where I guess North Star, the ski resort, is just out of Reno, heading sort of west, and you cruise down into the Sacramento Valley once you get over the Sierra Nevada mountains. So one of the groups left St. Louis late. They left in early April. You think that's late? Well, yeah, that was late, because if you're walking, or you're walking with oxen and horses and pulling carts and people and stuff, it takes a long time. And then to get over the Rockies, it takes a while. Then to the Wasatch Mountains, another period of time. It's just a long haul. And they ended up getting towards Reno, and someone said, dude, let's go for it. Yeah, we're talking about the Donner Party here. You can see from the name of the data set, Donner Party. And they got stuck near the town of Truckee, literally just east of Truckee, right near where that lake is. I've forgotten the name of the lake, but there were two separate cabins where the two separated groups in the Donner Party were housed up for the whole of the winter. And the question is whether individuals survived or not. And it may depend on whether they're male or not, and their age. Okay. So one thing you could do, if you had only a categorical explanatory variable like male or not, and then the response variable is did you survive or not, those two variables taken together, they'll form what I would call a natural chi-square analysis, a contingency table, if you will. Inside the context of JMP, you could analyze that with fit y by x. It's your friend, fit y by x. You might say survival or not may depend on male or not. They're both categorical. See the little red thing, categorical, not quantitative age. That would be a different sort of an analysis. You could
Dr. Rain,
see.
I don't think you're sharing your screen if you're trying to.
Yeah, I'm not. So I'm definitely going to do that. So sorry about that. Share the screen that you should be seeing. Okay, now let me sort of go back and talk about how to get the analysis done. So thanks for mentioning that, Jack. So under analyze fit y by x, you want to say, does a person's survival or not depend on whether they're male or not? Okay, there's different levels of survival, and logistic regression, the topic of the day, you only have two separate values for the survival variable, yes or no. I survived or I died. Okay, the categorical variable male has two values, but we're not limited to two values, but male is either a yes or a no. People are male or not. And in my analysis with the fit y by x, you could see this upstairs thing. It's called a mosaic plot. The mosaic plot sort of shows along the x-axis all the zeros for male, that is not male, all the ones for male, that is male. About 2/3 of the individuals who took the trip were male, about 1/3 were female. Survival, yes, that's a 1. No, that's a 0. Blue, survive, red, dead. Okay, overall, about 40% of the individuals survived, 60% died in the Donner Party. In the females, the rate of survival is larger, a greater fraction of this column is blue. In the male column, a smaller fraction is blue, a greater percent of the males ended up dying. You can see, oh, look, 33% of the males ended up dying. Here we have, shoot, fair enough. Never mouse down inside a graph. Okay, so just hover, hover, hover. Here we see 67% of those that were in the male 0 or female category ended up surviving. Okay, these data could be presented in what's sometimes called a contingency table. It lists off all the possibilities, male 0 or not, female males. Survival did not and did survive, dead lived. Among the males, there are 15, females, 15 females, male 0 means female in this case. We've got 5 and 10. Among the males, it's 20 and 10. The rate of survival among the non-males is male 0, non-male, 2/3, 1/3 did die. In the males, that's a male 1. We've got overall 2/3 survived, 1/3 dead. So far, it's familiar to many of you because you were in one of those prior stat classes where you saw a contingency table and a chi-square analysis. I'm going to say, I don't play that in this class. Yeah, chi-square is a friend, but I'm going to say instead of the Pearson chi-square statistic of 4.5, I'm going to recommend the likelihood ratio test. But shoot, these numbers are about the same. And it's got a p-value that's similar. The likelihood ratio test is preferred over a Pearson chi-square because it's more generalizable to more complex contexts. This likelihood ratio test is basically, can we say if there's no relationship or there is, null hypothesis, no relationship, the rate of survival is the same in both groups. Alternative hypothesis, the rate of survival is different between the two groups. Some of y'all might be wondering why have two test statistics? Yeah, great question. Are there ever two ways to look at a person? Like literally, if I was wandering down the street and I saw one of you who regularly displays your face I have I think 50% chance of noticing that it's you. Because I always get the front on view of you. You're looking at the screen. I'm seeing your face front on. If I were to be in a regular classroom, I would be able to see what you look like on the profile, doing this. And that's a horrible way to watch things in a class where, the video's over here. And so Anise is demonstrating for us. Thank you. So what my point is I would not have known that that's how Anise looks from the side unless she had turned the camera on. And so bumping into her in Ralph's and Los Osos, there's no way I would have a clue who she is, especially with the masks and everything. But the different perspective will answer sometimes the question differently. Okay. The likelihood ratio test is one way of looking at the data that usually agrees with the Pearson chi-square test. There is a third test as well, but JMP tends to not provide those results unless you specifically ask for it. I recommend likelihood ratio. What I'd like to do now is introduce the model that we'll be using for data in this logistic regression context. And I'll show you how you could get this likelihood ratio test via analyze fit model. And then we'll talk about how we could work with analyses like that, but in a more complex context. So let me just go ahead and move these guys off the way and I'll draw on my screen. Okay, so my model here is for the log of the odds of survival. Now I'm going to work with survival as one of the possible outcomes. If you want to figure out the chance of death instead of the chance of survival, it's the same thing, really. If I could tell you for an individual the chance that they die, you could tell me the chance that they survive. I could speak your language and you could speak my language, even though we might choose different values as our response, the response in question. I like the chance of survival because that seems more positive to me. So I'm going to say pi I is equal to the chance of death or a chance of survival for individual I. So, person 15 has pi 15, person 32 has pi 32. Now, the way we're going to choose to model that is the following. The log of pi I over 1 minus pi I, if you will, the log of the odds of survival. Those are the odds of survival. And if you're from Stat 218, you may be bumped into odds in the context of that class or an odds ratio, but I'm just saying that's just by definition what I'll call the odds. You could think if I tell you pi, you could calculate pi over 1 minus pi. That's the odds. It's just a rescaling. It's a renumbering of our ruler, if you will. Chances go 0 to 1, odds go 0 to infinity. Or I guess algebraically, we could work backwards. If I told you the odds, you could calculate pi from that value. It's called algebra. So the log of the odds of survival, I'm going to say that's an intercept, beta 0, plus, and I'm going to go with an effect of the individual being male. I'm going to call that alpha M and alpha F. Now, this is just like in the ANOVA context in our class. Remember how we had mu plus then the effect of being in one group versus the other, the alphas were the effects? We've still got effects here. In this case, it's across two groups. The effect of male, the effect of female on the log of the odds of survival. So not too bad. I guess if I wanted to do algebra, I'm going to say for just the males, if M, I'm going to say the log of pi I over 1 minus pi I is just beta 0 plus alpha M. If I were to exponentiate both sides, pi I is equal to e to the beta 0 plus alpha. Erase that, undo. Okay, alpha M hat. And I'll call that pi I hat. And I did algebra in, I did 3 steps of algebra all once here. 1 plus e to the beta 0 hat plus alpha M hat. But the upshot is, if I were to tell you alpha M hat and beta 0 hat in each of the 2 places, I could tell you the corresponding chance of survival, yeah? So what I want to do is to show you how to estimate these terms, the alpha and the beta, and to test a hypothesis that both of the alphas are the same as each other and 0. If both of the alphas were the same as each other and 0, in fact, that corresponds to Same chance of survival regardless of whether someone's male or no. Okay, so I'm going to go ahead and save that. And now that I've saved it, I can maybe show you later if need be. And I'm going to stop sharing this screen and sort of go over and sharing different screens. So new share. Oh, no, I don't have to. Oh, yeah. I just have to clear this. Boom. Boom, cleared it. Okay. Okay, did I clear this? Okay, I thought I clear. Oh, on my iPad, it shows something and then, yeah, it doesn't show it here. Okay, so now I think we're good. So if I had the data here, okay, under analyze, fit model, all I need to do is to say whether someone survives. If I drag a variable that's categorical with 2 levels into this response variable location, watch what happens to personality. You've never really paid attention to personality a whole lot before, because it always seems to like do normal things, linear things, like in ANOVA and regression. If I drag survival over here, it says, oh, no, I know you want to do a logistic regression. And I think your target level is 0. I'm thinking I am positive. I want to say the chance of survival. I'm going to say the target level is now 1 for chance of survival instead of chance of death. What may impact the chance of survival? Well, I'm going to say maybe someone's maleness may impact their chance of survival. It may increase, may decrease. We'll find out. I click run. Output here says a variety of things. One of those things in the output is this whole model test. That's like the ANOVA for the whole model. And it tackles the question, is at least one of our explanatory variables helping us? In my case, my chi-square for that says below 0.05. Yes, at least one of the variables does help. And I've only got one variable, whether someone's male or not. So I guess yes. Okay. And then separately, I've got variables here downstairs, the effects likelihood ratio tests. That's going to correspond to remember the effects test, controlling for the other variables. Well, I don't have any just yet, but controlling for the other variables that are possible. Do we have male standing out as different than the non-male individuals? Yes, we have the same p-value. This is the likelihood ratio test LR for likelihood ratio chi-square. There's my chance. I feel happy. Yay. What about this parameter estimate? This tells me beta not hat. This tells me alpha for the males. Okay, alpha for male level 0. I say, no, that male level 0 means for the females. So the female effect, if you will, is to increase something. It's to increase the log of the odds. So let me move my data over here and walk through a little bit of algebra. What we said to finish off last time was that the log, because the log of the odds, so I'm going to write that again, log of pi I hat over 1 minus pi I hat, that's an I in both cases, is beta 0 hat plus alpha of the appropriate alpha hat, M hat or alpha F hat. We've got the alpha at F hat shown here for us. A male 0 means not male. That's alpha F hat. And we have the intercept, that's beta 0 hat. So let's talk about just individuals that are female. So F's and let's again do the algebra on the fly. Pi I hat for females, the chance of survival is e to the beta 0 hat plus alpha F hat over 1 plus e to the beta 0 hat plus alpha f hat. And again, these are the entirety of the exponent. So let's write that out. And if one of you has a calculator, that'd be awesome. So this is e to the negative 3.6 times 10 to the negative 16. That's probably like 0. Plus then in the exponent plus 0.693 over 1 plus e to the about 0 plus 0.693. So I'm thinking I need to know e to the 0.693 over 1 plus e to the 0.693. And that numerically is, I know what it is because I've done this before, but I'm hoping one of you will tell me that this is. I'm looking at a couple engineers with their calculators going. I'm looking at a couple of engineers who aren't using their calculators.
Is it 0.69?
Let's go with 0.67. I did a little bit of rounding. Remember 3.6 times 10 to the negative 16. That's probably pretty close to 0 exactly. But the 0.693, if I had the 0.14718, you end up with the numerator is what? 2, and the denominator is 3. 2/3. Now, if I remember, that matters. Where did we see this before? Do y'all remember of the male zeros, females, 2/3 were surviving. That is also the among the non-males, the survival rate, this row percentage in the 15 individuals, 10 or 2/3 of them survived. Survival rate, 2/3 of the females. That's what we got right here. Yay. Okay, so that's a simple analysis. Let's clear that. Let's make life more fun. Did y'all notice that we had age as well as sex, being male or not? I think age could have an impact on one's chance of survival. I'm imagining the old and relatively frail people are more likely to die. Younger people are more likely to survive. Besides gender, for whatever reason, age may have an impact. Okay, so let's complexify our analysis. Under fit model, we can do that with ease. I'm going to hit recall because that's good for me. And I'm going to put age here also. Male and age could both possibly separately have their impact on the chance of survival. This is a model without an interaction, by the way. But I could do a model with an interaction if I wanted to. Y'all remember how to do that. You just click male and age and hit cross. We could include that if we want to at the next stage, but I'm just going to for now hit run. Okay, so going through things that you need to know for the lab, the whole model test. Oh, yeah, at least one of my 2 variables is helpful. At least one of the 2 variables helps me predict the response. At least one of the 2 does. Going downstairs under our effects likelihood ratio test. Maybe I should skip over the lack of fit. The lack of fit is helpful in a different class, not our class. 418, stat 418 is where that might come up. The effects likelihood ratio test, these are effects tests. So controlling for a person's age, is there a difference between the 2 genders? Yes, there is. And controlling for whether someone's male or not, is there an effect, a slope, if you will, for age? And the answer is yes, there is. Not bad. So let's look at how our model has been fancified. Just like we had earlier done with our general linear model, we still have something that looks like some sort of response has a linear function relating to the X variables. In this case, the log of the odds, log of pi I over 1 minus pi I equals beta 0 plus beta 1 times X. That's age, my quantitative explanatory variable. Plus, I'm going to have alpha F and alpha M, depending on whether the individual is male or not. Non-males first, males second. Okay, so let's just say, what if we want to see what that slope thing looks like? I guess I could look down here in my parameter estimates and say the slope of age is negative. Well, negative, hold on. If survival is the response that we care about, negative suggests that the older someone is, the less likely they are to survive. Yeah, makes sense. Matches my intuition. But I could, for each the males and the females, for each group, I could separately say, what is that relationship between X and the log of the odds of survival? Or I could tell you that pi I hat, the chance of survival is e to the beta 0 plus beta 1 times X plus then, and I'm going to say, what if someone is female now, alpha F hat. I'm going to put hats everywhere in sight, over 1 plus e to the beta 0 hat plus beta 1 hat times age plus alpha F hat. So it's just math. If I were to tell you the alpha hat, and I know that there, if I were to tell you beta 0 hat, that's now 2. And if I were to tell you the alpha F hat, that's 0.79. If I were to tell you the slope, 0.078 negative, you could then go ahead and for any particular age or for any particular individual, they have an age, and then whether they're male or no, you could plug and chug and get your pi hat out. Fortunately, the software will do that for you. So I want to show you how to easily get that. I'm going to sort of drag our data over here, but adjust this way it's looking here so we don't sort of cover up the screen. For each individual, they have an age and whether they're male, yes or no, 1 or 0, and they did survive or they did die, 1 for survival, 0 for did not. Over here under a nominal logistic, I could say, I want to save the probability formula. That's going to create 3 new columns. The chance of surviving, the chance of dying, and something called a linear. Okay, that linear here is corresponding to literally beta 0 hat plus beta 1 hat times X age plus alpha F hat or alpha M hat, depending. That linear thing, e to the linear over 1 plus e to the linear is the chance of survival. 1 minus that is the chance of death. The prob 1 is the chance of surviving in the way that I've fit this. I've saved these residuals for a reason. With Graph Builder, I now can display what's going on. So let's use Graph Builder. And if I clear the equation away, are y'all okay with that by now? Okay, I'm going to save it and then clear it. Good. So if someone needs it, I can reproduce it and mail it to them. Okay, so under Graph Builder, where is Graph Builder? Okay, so under Graph Builder, I've got a variety of variables. Presumably age may impact things. Male or not might be 2 separate groups. Yeah, blues for female, red for male. And shoot, I'm obsessing now because I like things to look nice to me. And I'm missing one thing. Oh, yeah. Notice how some of them have been highlighted. I don't want that. Now it looks pretty again. Okay. And displaying there. Boom. So now everyone's properly in full color, blue or red, not some of them sort of partially grayed out. And I want to do along the x-axis age. I'm sorry, survival is along the y-axis. So survived 1, did survive, dead 0. Here's the actual raw data. A couple things you could take into account. One of them is this thing called jitter. Notice how like they're spread out. You've jittered them about a little bit. If you make them narrower or wider, it has some benefits or drawbacks. I like as narrow as possible. I can still see them all. Blue are female, red are male. The males tend to be older and more likely to die. If I turn on my slider for this smoother, it does maybe overdraw things. It sort of shows a trend. Maybe I don't like that so much. That's not really what the model says. Here are my data. Let's under probability of survival, take probability of 1 and put that, the chance of survival here instead. Ah, that looks like a model. Now I'm going to add in that. Yay. So I have my chance of survival for the blue group. The female starts out at about 90% for the younger females. And as they get older, it drops to a little bit below 40% for a female. It's about 50 or so. For the males, they start out at about 60% if they're, younger, like age 15. And these are only those that are age 15 and up in this data set. There's a more complete data set with kids under the age of 15 as well. These are just the nominal adults. Some of you are thinking 15. Well, back in the day, that was called an adult. And so males had very little chance of surviving if they're age 60 or up. So we have these two curves, one for each group that was fit. Yay, you have a good sense for what's happening here. Between the effects likelihood ratio tests and then the graph builder, you could describe what's going on. Males are more likely to die at any given age. And the older someone is, the more likely that person is to die. The one wrinkle that we haven't tried is something I hinted at earlier, and that is, what about an interaction? Might it be that this slope, which is, I'll say parallel, presumed to be the same across both groups. And when I say parallel, you're sort of saying, yeah, it don't look parallel to me. Ask yourself, if I took the red curve and slid it over to the right, could it perfectly match up to the blue curve? Yeah, that's the way of parallel. Parallel meaning you slide the one to the left or right and you get the other curve. We have a parallel line structure here. But I don't see any reason why that would have to be true with fit model. I can go ahead and recall my models thus far. I'm going to hit age and male, cross the two, and assess in my output whether there's a statistically significant interaction, a 0.048 interaction. P-value says there seems to be a slight difference in the chance of survival as a function of age. If you will, there's a slight lack of parallelness. The slope before we did the e to the power something over 1 minus e to the power something, the slope seems to be different between our two groups. Let me do one more time. The construction of my estimated chance of survival, because you get to do that in the lab, so why not start you there? under our analysis output, and that's with the interaction. I'm going to save the probability formula. Click there. And it's going to say, well, I had my earlier stuff, prob 1 and prob 0, prob of survival is prob 1. Now I've got a second version from my new model. Let's go ahead and try Graph Builder yet again. My prob of survival, my second version, and survival is a 1, may depend on the age, and it may do it differently for each of the 2 separate genders. Yeah, crossing. Definitely a lack of parallelness here. This is all to say that, yeah, in the males, the older they are, the more likely they are to die. In the females, the older they are, the more likely they are to die. But basically, younger females all survive. But if the female hits age 45 and up, probably not likely to survive, just like the males who are older, but they still have a slightly higher chance of survival according to the data we have thus far. Okay. So none of you interrupted me, and that's probably because I had a good lecture buzz going. I like logistic regression. And so because that, if someone put something in the chat, or if any of you were trying to flag me, I was looking at my screen and I totally ignored that. I should have paused and said, hey, do any of you have questions, at several points in time during that, but it's better to ask now than not ask at all. Do any of you have questions about logistic regression or any part of what we've just done?
Yeah, I have a quick question.
Yeah, Jack.
When we were talking about the pi hat I, where we had E over 1 plus E, you said that it would give us that number so we didn't have to do all that math.
Oh, yeah.
Where
Right
would it
there.
tell us that?
Boom. This is it.
Okay.
That column,
that's-
yep. And
That's the
it's
chance of survival.
yeah, or the chance of death.
Okay.
And that's not hard to do by hand if you have only categorical variables and only a couple levels. And I'm going to ask you, because this is the disaster data set day, I'm going to ask you to sort of deal with the Titanic data in your lab. And there's 3 different first class, second class, and third class passengers, and then the crew. And they have different rates of survival, perhaps. I mean, you'd think if you're stationed below, if your sleeping quarters are below the water line, maybe it's less likely to survive than if you're up top, on top of the ship. We all saw the movie. By the way, I hated that movie. But we all saw it, and you get a sense for the different classes of individuals may have a very different chance of survival. The data set sort of bears that out. So categorical only explanatory variables, yeah, it's not so bad to do it by hand. The other data set that I've asked you to look at in the lab is the catfish data set, and whether there's an American shad, Alosa sapidissima, inside the stomach of a catfish or not in the James River. And each individual catfish that was caught, we know the length of the catfish, we know the species of the catfish, and we know whether there was a full-on American shad or even remnants of a shad. You can tell from the otolith or the ear bone of this particular fish species you can tell it's a shad. So we know whether there's a shad in the stomach or not from the stomach contents. And so the chance that the catfish ate the particular fish that we're trying to save in Virginia is a function of the length of the catfish and the species of the catfish. The method is really nice if it does it for you, and it's under save probability formula. And it saves the chance of both success and failure, or having a catfish, a shad or not, if you will. Great question, Jack. Thanks.
I have a question.
Yep.
Can we just take a step back? just a little bit more basic question. Why would you use this analysis as opposed to other types that we've used?
Okay, so yeah, that's where I sort of started, but I was pretty quick when I sort of just said, "Shoom, let's just jump." And I apologize for that. If you have a response variable that's either a success or failure, living or died, like if I'm planting seeds, and if the seeds will sometimes survive, but sometimes they die, my explanatory variables could themselves be used as predictors in a logistic regression for whether the seed sprouted or not, or whether it, maybe if it did sprout, whether it survived until, it flowered or not. So yeah, success or failure data, logistic regression is the way to go with that.
So for both your X and Y variables, do they both need to be categorical, or what would a continuous variable look like when using it in this?
Yeah, sort of like this one. Age is continuous as
Okay.
a predictor of did you survive or not. And here I'm plotting the chance of survival as a function of whether someone's female or male, and also age. So it's
Okay.
only the response variable that needs to be categorical, and it has to have two separate levels. If there's 3 types of outcomes or 4 different types of outcome levels, it's a different method, but it's
Okay.
nominally, I should say nominally, it is going to be based on or similar to this, but a mathematical extension of the concept of logistic regression.
Okay.
Multivariate response data, yeah, it happens.
But we'll only really be learning about the 2 levels.
Yeah, and only today. So this is it.
Sounds good. Thank you.
If it's in the lab, it's possibly on the final, and if it was in the lecture, it's in the lab, and if it was in the lab, it was something we talked about in the lecture.
Cool.
I had one more quick question regarding parallelness and lack of parallelness. Could you just go over again what that means and what that tells us?
Yeah. Oh, so when I say parallel, what I mean is that there is no interaction. So if I say the log of pi over 1 minus pi is beta 0 plus beta 1 times x plus alpha f or alpha m, depending on f or m, those are 2 parallel lines, right? What we see on the right-hand side in this equation, we've got 2 lines, 1 for each, the f's and the m's. Actually, I drew those with the wrong slope. I'm sorry. But in general, you're going to have 2 separate parallel lines. The problem is the left-hand side, we've got the log of the odds. And if you translate that into pi, these 2 parallel lines, and maybe I'll make one of them blue and the other red for fun. And then once we translate into pi, we're going to have the red to the right, and blue will look the same, but it'll be shifted over to the left a little bit. So in other words, and I'm going to go with yellow here, the amount that you shift over here equals the amount you shift over there, like here, parallel in that sense.
Okay, and then when they crossed, that shows us that there is an interaction effect.
Yeah. Or if I were to take the red line here and shift it over to where the blue line is, would the red and the blue overlap each other perfectly? If the answer is yes, parallel line, no interaction. If the answer is no, there was an interaction.
Awesome. All right. Thank you very much.
Yeah, but absolutely everything we've done this term in the general linear model that we've considered translates into this 0 or 1 response variable context. And I don't want to sort of overdo it. And there's a lot of other more beautiful mathematics here. But I'm saying as long as you say use the likelihood ratio test, it's just like an effects test. And the overall model test, yeah, that's up at the top. There's a nice parallel structure to what we've already learned and now applied in the context of a 1 or 0 response variable. So if y'all don't stop me with an additional question, I'm going to stop the sharing and stop the recording and put you all in breakout rooms to do the lab with the Titanic data and then the catfish. Y'all good? Okay, recording is